it should be always a new module. Usually you would go here in a test, you would rename this to something like function tests. And then it's a new module, which is again function, be the same name, tests. And you will have to import SWI or 0x2, whatever you like, test scenario. So this is how you do it. So testing SWI go as if you would create a new blockchain from scratch that is empty and you're doing every transaction step by step. You have to add this, how do you call it? I'm not sure. You have to write this line of code if you want to make it a test. And there are some functions, if you write test only, it means that it's going to be used in test, but it's not going to be run as a test. So if I want to check, create new message. Then what you would have to do is we are going to call new container. You will need an address. So usually we do that as a const. Let's say it's a user. This is going to be an address. And yeah, you can give whatever random number you want here. And then you have to set up the scenario. The scenario is your blockchain. So I will name it just this, and I will name it just TS because it's much easier. The scenario begin. So this is, and here you need an address. That's why I did a constant over here. And then after begin, you can write a new transaction. This block is not necessary, but I like to use it in order to be more readable. So what we want to do, we don't have any need function over here, so we just want to call new container. We just need the message. This is going to be easy. I'm going to write a message. And then I need to import. And this is again 0x0 or contracts if you want. We named it hello world. So, and I will name it as module. So from module, I want to call the new container. The message should be a string. So I need to make this to string. And then the context is within the scenario. So you just call this, and this will return the NFT, the object, actually. Okay, this needs to be mutable. Make this bigger. And now that you have an object, this is again a function. If you have an object that has a key, you have to either destroy it or transfer it or give it to another function. You cannot just leave it over here. So I will just transfer it to the user. And when you're done, you just do scenario end. And now if you write stream test, sorry, you have to be in the folder that has the move toml. So swing of test. I have some warnings, but yeah. So the test passed, nothing went wrong. What we could have done next, so you go ahead and you call the next transaction here. again for the user. So this is the first transaction. This will be the second transaction. After this finishes and everything we did here, like we create a new object and transfer it to the user, we can go and take the object from the user. And you do that by scn take from sender. And sender over here is this guy. So whatever address you put over here, and in order for them to know what to take, you would have to give the type. And this is done as follows. This is a message container. Yeah, so you have to tell them, you have to tell it over here, you have to search for any item that it's of this type. And if there's no such item, if we didn't do this, I would get an error. Sorry, I would get an error. And oh, getters. Here I'm missing some usual functions that are, what do I need here? I need a message. Get message or just message. And so message container. This is just a read-only reference because I just need to get the message. And I will explain right now why am I doing this with self-message. I did all of this because over here I want to read the message and I want to make sure that it's this one. So I'm going to take it out of the block over here. And then what I want to do actually is object.message equals message. I want to assert this thing, if it's true or not. The problem is I cannot do this. This can only be done, so object.message can only be done in this module because this is a module where we define the struct. So because I cannot do this, I need a function that allows me. So over here, if I didn't want this function to exist or to be allowed for other people to use it, I would just write here test only to use it on my test. And what I have to do, so I want to assert, this is how you assert that the module, so actually it's object get internals. So in this case, yeah, it's return to sender, not to sender, to return shared clock. Yeah, now it's correct. Now it's telling me that there is no clock. Yeah, it's telling me that it's no clock because I need the new transaction over here. So you have to do this next transaction every time because over here, this is one transaction, but these blocks are just for me for readability. This called block. It's not really necessary. It would work without. So if I don't put a new transaction, these things, the next, it will be in the same transaction as this one. So in this transaction, the clock was created, it was shared, but in the same transaction, you cannot access it. So it has to go to the next transaction in order for you to be able to access. So, oh, and of course, yeah, okay, the time is 0. We can also increment it a bit. This takes a U64, we can say it's this number. Okay, here it is. So my suggestion is write test, like write unit test, make sure that every function is doing what it's supposed to be doing and keep them there. Here we wanted to also change the author. Last time, but now that I think about it, this isn't the way that it should happen, because message container is an owned object, right? So if you have an owned object and you're supposed to put it as an argument, you can only do that if you own it. You can only do that if you're the sender and the signer of the transaction. So if I want to change here the author, it means that, oh yeah, I can do that. Yeah. If I want to change the author, it means that the author is someone new. This implies that it got sent, but this is a scenario that can happen. So I can own this, and at some point I can call a transaction that just sends it to someone else, and then someone else tries to change the message. When that thing happens, I want the author to also change, so I can do just change author, and I will give the container, and the author, it will be the sender. Of course, if the sender didn't change, nothing will change. But it will be like this simple to do this. Now, let's deploy this. Actually, I have, yeah, this is something we don't need yet at all. And actually, let me also write an assertion. We wrote an assertion first, but let's say that we have a ban list or something that I don't want someone to be able to change messages. For some reason, usually you would have a state, you would have a shared object that has a whitelist. In this case, I would say that if the sender is this address, now I will just hard code it. I want to abort, like not allowed. And this is an assertion. This is the way that you actually check for things that you want to happen. So here it should be a formula, an expression that evaluates to a Boolean, to a true or a false. And it should evaluate to true when for things. No, it should be like this. So this thing should always be true. And so if this thing is true, the program continues. If this thing is false, then you get an error and the program stops there. It throws. And the errors remove are numbers, are U64, so it's error codes. I could have put the number here directly, but usually it's easier to write it like this. What you will see when you're calling this function, if you do hit this error, you will see this number. And then you would have to check the source code, and that's why we write here an error that actually hints to the reason why it might have happened. So you don't actually need to actually go to the whole code. And this is the reason why we write them like very high in the contract. We start with the errors. So if you hit 101, you come here, you read not allowed, maybe you realize what went wrong. If you don't realize what went wrong, of course, you have to go to the function that you called and check what actually went wrong. In this case, this error can never happen because only in test. So in test, it can happen, and let me show you how you can write the test that it's supposed to fail. You do here an expected failure, and it's very indicated to write the abort code that you're expecting. You can actually import it if you want. It's better. You go over here, you import it. Oh yeah, here we need a CTX now. So let's take the scenario from here. And let's do a new transaction. In this transaction, so it should be the user. So the user first transfers their object. So I'm getting the object again from the user. And then it just transfers it. As I said, you need to transfer it first. Otherwise, only the user can call the change message. To 0x2, which is the address that we said we don't want to be able to change the message. So in the next transaction, I will do it as 0x2. I will get the object again. Now that I have transferred it, I should have it. And then I will try to change the message. Okay. But you also have to write correctly. So you have to return the object. Even though this will fail here and will drop, we have to be correct over here. So we could do a test here. So even the third test passes, it was expected to fail. If we had another abort number, it would tell us that test did not abort with expected abort code. And that is why it's very useful to always have the correct abort code, because the test might fail or the scenario might fail, but it might fail in a way that you didn't expect and you wouldn't catch it. Okay, let's deploy this onto the chain. Let me check my environment. I will do it on Internet. Yeah. Please. So yeah, for smart contract development, you have to really know move, and you have to be really clear of what you're trying to do. Usually, when you write a move contract, if you don't have a design doc and in the beginning move like that, you won't know exactly. So maybe I'm going to add something new here, and I need a new test later, and stuff like that. So you will doing twice the job. You will write all the tests. You will do one change here. You will need to change all the tests, and then you will do another change in the contract. You will need to change all the tests again. It feels that it's not efficient at all. Most people don't do that. If you feel that you could do it, it would be the best approach, of course. But it's quite difficult to do it. There is no model that does that. I know Claude can write some move, but you should always double and triple check it, especially if it's some very important, like some DeFi with a lot of volume and stuff like that. ChatGPT won't be able to do it at all. So it will always write some things that don't exist. They will create a coin from nowhere. They will do stuff that it's not doable in Move. Cloud is a bit better, or maybe quite better. I don't know the new version, but it's not there yet. There are not enough data points for to train an LLM on Move because there's not enough Move written yet, it seems. Yeah, of course. A lot of people have tried that, but none has succeeded yet. Maybe if you can do it, it will be best. Like Copilot can actually slowly learn, and he can help you a lot, but he will do mistakes. You will have to delete many of the lines. That's why I'm not even using it. But with the names and stuff like that, he can actually guess what you're trying to write next. But he won't be able to generate the correct function. It can help with tests. I think with the tests, it can help a lot because tests, if you see, I already wrote 98 lines of code for test, and it's only 50 lines for the whole contract. So the tests usually are 3 times or 4 times more lines of code than the actual contract, and there is a lot of copy pasting. So yeah, for the test, I suggest you can use Copilot, but you should be here and should be actually trained, like see you how you write, and then slowly trying to help you. And after a few contracts, you will get better and better. So I moved to DevNet. I have no coins, so I'm going to do a faucet to get some coins. Oh, I did it fast. I wanted to do gas now. So I have 2 coins. I have the suite. I have 20 suite. I can publish really easy. So if you want to publish, if you're in the same folder that has Tomo, you just do suite client publish, and this is all that you need to do. It will build again. I'll check if it builds, and then this is the response that you get. Let's read it together. This is transaction digest. Every transaction has a digest. This is their unique identifier. So if you go, can you see my screen now? Are you seeing VS Code or are you seeing Firefox? Okay, I will show it later. So yeah, if you want to check it in an Explorer, if you put this in an Explorer, the digest, you will get a transaction and you'll see the same things. Actually, the sender, who did it, who is the gas owner, because some transactions can be sponsored, the input arguments. You don't care. Actually, you care about the effects, and the effects are also translated into object changes. So this is the objects that have been created. There's an upgrade tab that allows you to upgrade your contract and change the code after it was published. This is the mutated objects. This is the coin that I used for gas. It says that it was changed because it lost some suite. And published object, this is my package. Again, if you want to check it into Explorer, the package ID. The packages are also objects. So you just go to an Explorer and you'll see actually the bytecode over there. I will need this because now I want to I will install @mysten/suite. So this is the SDK for TypeScript, and I want to call a function. So I will need the package ID. Let me copy it again. And let's do a script. So yeah, you will need the package ID for sure. And you will need any other ID that was created, especially if you create shared objects and stuff like that. What you need is import transaction from Mysten Suite. So this is what you need. So let's do a new container. And you do TX. I usually name it TX. This is a new transaction, and the only thing that you need to do over here is TX move call. So you have to give a target, which is which function am I going to call, and then you will have to give the arguments, which are what are the arguments of the function. The target in this case, it's always the package ID. The package ID over here used to be 0x0. I think I didn't even write. Yeah, it's 0x0. This is the thing that happens in MoveToml. This is being changed. So after it was published, we changed to this. So this is a package ID that I need, and I have it over here. Then double semicolons, you need the module name. So this would be the module name over here. And then you need the function. So in this module, I'm trying to call this function. And then I need the arguments. Sorry, if it takes arguments. This is an argument that you don't have to add, you never have to add, but I need to add the message. So for arguments, if it's an object, you do tx object and you add their ID. No, this is incorrect. Yeah, you add the ID. If it's something that it's a primitive, we said that strings are not primitive, but for to make things easier, here it is we call it they are called pures and not primitives. So you just do a pure string and it will be created in the string my new message. So if I manage to execute this function, I will be able to actually create this subject and chain. In order to execute the function, though, you need a client, and a client is just a SWI client. It's being imported here, and you need a URL to the RPC. And there is a get full node URL, and you tell it devnet. So now you have a client. You can read stuff from the chain. So if I do client get the owned objects, I can read what objects an address has. If I do client get balance, I can get the balance of an address. If I do client get object, I can read an object, and so on and so on. You should check it out. Now what I want to do is I want to execute the transaction. So and this should be an async function. Client sign and execute. You have to sign it and execute it. The transaction will be this, but you also need a signer. And now I will have to create a signer. And I have, so maybe I will stop sharing. I will show you what I'm going to do. I will do this, or let me go here. So if you want to find the addresses that you have in the CLI, you just need to go to your home directory, SWI config, swi.keystore. And if you do this, it will show all the private keys that you have in oh yeah, we can only see VS Code. Okay. Sorry. I would show it on VS Code. So then, sorry. Let me copy it. Okay. Yeah, I did this. So in the Swift folder, make this bigger. How do I close this? Yeah. So in your home folder, Swi config, Swi key store, you will find all your private keys in B64 format. So I will take a private key. This one I don't mind sharing, and it's smaller. So I went ahead from there, and it was yeah. Wait, because I couldn't copy it. Uh, so if you have this in, you will need to because like key in array, it will be from base 64, and if you do this, you will get a uint data array. There is a problem though, so I have to turn it into an array, and then I have to throw the first byte. So the first byte in Sui, you can have 3 types of private keys from 3 different cryptographic schemes, and the first byte, it can be 0, 1, or 2, depending on the cryptographic scheme. In this case, I made it with EDDSA. So I know it's the first, I'm just throwing a 0. So I know I'm going to throw the 0. So it's key array. No, sorry, I just need to do key array shift. So shift will throw the first byte out, and then I can say that the key pair is an EDDSA type of key pair from secret key. I need the uint 8 array though, so I have to turn it again back into a uint 8 array. And this can be my signer now. And then you can have some options over here, like show effects if you want to see them. Like when I did the publish, all of these options were true. It's show effects true. It had show object changes also true. And I think it had show balance changes also true. You can check the options. Usually you want to see the effects, and if you have events, you want to see the events as well. We don't have events yet. And then we can console the response. So yeah, if I call this, I should create a new so I did, oh, I got an error. What's the error? Oh, and news, oh, I create, okay, so I create a new container, a new object, but it's not getting transferred. So I have to also transfer it. The command for this is transfer objects. You can transfer more than one, and you have to give an address, which in this case, you can get it from the key pair to SWI address. And also, I'm not sure if I have gas. No valid gas connection. Let me log the address. Yes, get this address. And let's hope that it will allow me to call the faucet again. So this is the address. It's the 0x38 SWI client addresses. I'm on this one. So I will do a SWI client switch address to this one. And I will do a new faucet. Request successful. straight line. Yes. Now I have enough, so now I can actually. And now it's succeeded. This is digest. If I take it to an explorer, I will be able to see it, and it will show me the same things, like a bit more readable. The effects are what was modified, what was created. Actually, it was created. This object ID, this should be the address for the object that I created. What was changed, which this should be the coin, I guess, or this is the coin. Object changes. We can see then the object change is shown better. So the coin that was changed, and yeah, and the message container that was created. This is the ID. And actually, let me share my screen. Over here, if you go to any Explorer on DevNet, you should be able to see that there is indeed a message container. It has the ID. It has the message that I told it to have. And the author, of course, is the same as the owner. And yeah, we'll stop here for questions, and we can continue next time with dynamic fields and some more advanced stuff.
Do you have some libraries for generation objects for TypeScript from move, like in Solidity, we can generate ABI and make from there some objects?
Sadly, no. Whenever you want to call, yeah, you need access to the source code in order to be able to see the arguments. The way I showed it, there are no ABIs or something like that to show you the. Maybe someone will do it. This is another good idea for a tool. I don't know if it's helpful or not. I know it's a fun idea, but for now there is no such thing. You actually don't. You only need to know the package ID that you're trying to call, the module and the function, and then what the function takes as arguments. You can read it from the bytecode. So if you know the package ID, you can go into an explorer, or you can use the client that I showed you and do a get move normalize module, and you will get the thing that you call an ABI. You will get the whole bytecode, and you will see exactly the argument. You'll see that the first is a string, and then it's, I don't know, an object of type coin or stuff like that. But the answer is no. The short answer. Oh, fuck. I will push soon. I just added the node modules by mistake. Let me delete them, actually. And let me add the node modules. Yeah, I'm just pushing the code to the same repo. Yeah. And next week I will be like, yeah, we can do any day. I'm not traveling anywhere. Okay, thank you very much. See you next week. Bye-bye.
Thank you. Bye.